Okay, so just going to look at this graph here, and I'm going to look at how we could use this model and we could solve it, looking at solving something graphically and algebraically and how the two things to relate. So say you were looking at a height of 1.2 meters and we have this graph here, h equals 0.2 sine of plus 1.2. And we want to solve it at 1.1 meters, okay? So when you're looking graphically, this is a shift of up 1.2. That means it'll go up to 1.4 and it'll go down to 1. I potentially could draw like a better scale than this. So 1 would approximately be there and there's 0. Now if I was looking at the period would be 2 pi on 40 pi on 75. The pi's will cancel out, and if you did 2 divided by 40 on 70, you end up with 15 on 4. So that just means that your period would be, if I make that a decimal, that is 3.75. 3.75. Halfway, if you divided that by 2, would be 1.875. That's how many hours from mid-tide, because it's a sine graph. If it's a sine graph, it's starting here. So you go like this. Okay, so that's your sine graph. Now, sorry, I just need to make it, we're going to make it, that's halfway there, and that's the full thing. So you go like this, and that's your sine graph going like that. Okay, this is your h, this is your time. Now, when you're looking at graphically, where the height equals 1.1. If you go to 1.1 here, the graph will equal 1.1. And I'll just stretch this out a little bit. At 2 times, it'll be whatever these 2 times here, okay? Now, if you enter into Desmos, you enter your equation, which is h is 0.2, sine of 40 pi t, or whatever you have, plus 1.2. If you enter that in, you enter h equals 1.1, then this is h equals 1.1, and the other one is your graph. Then the point of intersection of these two things, like this one here and this one here, the point of intersection, if you get those 2 times, would be the same as if you solved it algebraically. Now on Desmos, if you run your cursor along here, you will actually get those points, and that's the significance of it. So all you got to do is put in the height that you want, and you put in the equation, and the point of intersection is the same as the algebraic solution. So let's just look at the algebraic solution to this. So if I put in 1.1 there, and that's 0.2, and that's sine 40 pi on 75t plus 1.2. If you minus 1.2 on both sides, you get minus 0.2. And here you get 0.2, and you go sine, and you got 40 pi on 75t. Then that means that sine 40 pi on 75t will equal minus 1. Okay, so where is sine equal to minus 1? Okay, so sorry, I can just see I've just made a calculation error. That should be 1.1. Okay, so that means that'll be 0.2 over, that'll be 0.1 divided by 0.2. Because if you divide by 0.2 and 0.2, you end up with minus 1/2. So where is sine equal to minus 1/2? Well, sine is negative in those 2 quadrants. So the first thing you have to do is you get the acute angle. I'm just going to call it theta. So the acute angle, you go sine the minus 1 of 1/2. You don't need to put the negative in because you just want the acute. And that will give you 30 degrees, which is pi on 6. If it wasn't 30 degrees and it was like, say, 40 degrees, 5 minutes, you're either going to use your radians button in your calculator, or you need to times by pi on 180. Okay, so 40 pi on t on 75 will equal pi plus theta and 2 pi minus theta. That's because it is in these 2 quadrants here. So that means that you have 40 pi t on 75 equals pi plus pi on 6 and 2 pi minus pi on 6. So t is pi plus pi on 6, and this it's all in radians, divided by 40 pi on 75, because we're trying to solve for t. And then you go 2 pi minus pi on 6, and you go divided by, and it's 40 pi on 75. So you work out these two times, and the first one you get is 2.1875. And if you press your, you press this button here, that will be your degree minute button, and it will give you 2 hours and 11 minutes, and there's 15 seconds. You don't really need the seconds. And then if you go 2 pi, you get 2 pi minus pi on 6 divided by 40 pi on 75. You get 3.4375. And if you press your degree minute button, you end up with 3 hours and 26 minutes and 15 seconds. So that means whatever time, like if you're, say, whatever time it is at the start of your graph, this would be how many hours after this time. Okay, so if you go back to your graph and you look at 2 hours 11 minutes and you look at the graph, can you see that that's where it fits in here? So that would be your 2 hours 11 minutes just there. And then 2 hours 11 minutes. And your 3 hours, okay, so your 3 hours, let's come back here, your 3 hours and 26 minutes, that would be on the graph. Let's go back here. That would be your 3 hours and 26 minutes. So the significance of the point of intersection graphically is that basically it is the same as the algebraic solution. Okay, you've just got to be careful when you do solve algebraically for the time. You do need to make sure that it is in radians. So you've either got to switch your calculator, or you've got to times your answers by pi on 180. Okay, and then when you solve the algebraically, the two algebraic solutions, let's just say it's for the height being a particular thing, whatever it is. So whatever, let's just say it was like the 1.1 for example. So whatever graph you've got, wouldn't matter what graph you've got, I might just put it oscillating up there because that's similar. Then the two algebraic solutions, whatever you get at a particular height, even if it was here, will be the same as the point of intersection of the other two solutions. Now I'm just going to do one for a Cos graph. So say we have a Cos graph and we had minus equals minus 0.8 cos 30 pi on 78t plus 2.1 meters. So if we wanted to find the times when the height is equal to, let's say 1.5 meters. So graphically, what that actually means is if you went up to 1, 2, 3, and you went up to 2.1, okay, so that's because the center is 2.1. It is a negative Cos graph. So a negative Cos graph will start, if you go 2.1 and you minus 0.8, that will be 1.3. Okay, so if you went down to 1.3, okay, and you start there, then you go up, then you go there, then you go there, then you go there. Alright, okay, so if we look at that then, that's our graph, and it has to go up. So if you went, let's go 2.1 plus 0.8, that will go to 2.9. So the highest point here is 2.9, and it goes up to 3. Okay, so there's our graph. Now if we're just looking at the period, we'll just look at the period. So you can enter this straight into Desmos, or you could just do it, if you did it by hand, this is what it would look like. So if we find the period here, you end up with 5.2. That means one oscillation would be 5.2. If you divided that by 2, that would be 2.6 halfway. So that would be 2.6. Okay, if you divided that by 2, that would be 1.3 at this point. And if you did 2.6 plus that answer, you get 3.9. And that's basically what your graph looks like. So the significance of, if you wanted to solve it for 1.5, if you put in the line y equals 1.5 or h equals 1.5, depending on what variable you're using, 1.5 is about here. Now when you do that, there are 2 points of intersection. And when you read those times off, those 2 points of intersection, so the intersection of the two graphs, of the line y equals 1.5 or h equals 1.5, the vertical axis for that horizontal line, will be the same as the algebraic solution. That's the same as the algebraic solution when you make your equation 0.8 cos 30 pi on 78t plus 2.1 when you make that equal to 1.5. Okay, so we're just going to look at solving that, this here, look at solving it algebraically. So algebraically, if I take away 2.1 from this, I get minus 0.8 cos 30 pi on 78t equals 1.5 minus 2.1 equals minus 0.6, and cos 30 pi on 78t equals minus 0.6 on 0.8. And that will equal minus 3/4, or actually plus 3/4, because it's minus 0.8. So that's going to make a minus, and a minus is a plus. Okay, so if we look at what quadrants this actually happens in, where is cos positive? That's in 1 and 2. So you go 30 pi on 78t equals, so it's going to be theta and 2 pi minus theta in those quadrants. Now, the thing is here, when I'm doing that, I then have to get the acute angle theta. So the acute angle theta would be cos the minus 1 of 3/4. Now, if I don't put my calculator into radians, I'll just get 41 degrees. So you need to change it to radians. So you can either just times pi on 180, and it's a good idea to store this into Desmos. So it's shift pi divided by 180, and I get 0.7227. So I'm going to put it into memory. So you go shift. Now there's a little button there that says store and recall. So it looks like this. So it looks like this button here. Okay, and to get to it's yellow, so you have to press shift, store, and then what you do is you press M plus, and then M will come up, and that means the 0.7227 will be in there. So your angle now, 30 pi on 78t equals 0.7272 and 2 pi minus 0.7272. So t equals 0.7272 divided by 30 pi on 78, and 2 pi minus 0.7272 divided by the 30 pi on 78. Because all we're doing here is just getting rid of the thing in front of the t by doing the opposite operation, which is division. Okay, so you can use recall memory divided by that, because that number's stored in there, and the same here, 2 pi minus recall memory plus, then it'll go, and divided by 30 pi on 78. Because if you look at this, there you go, there's the recall memory, and that will recall what's in it, whereas the other one will store it. And I get 1.1333 ... and if you press your degree minute button, which is on the calculator, that one there, then you will get 1 hour and 8 minutes. And then there's a little bit of seconds, but we won't worry about that. And doing the second one, it's 2 pi minus, recall memory, and then you just divide by, and use your fraction button, 30 shift pi over 78, and you'll end up with, and I end up with 3.1286, and it keeps going on. Press the degree minute button and I get 3 hours and 8 minutes, because it goes 7 and then 43, and you've got to round up. So the significance of this to the graph, if you think about those two times there, 1 hour 8 and 3 hours and 8, and if you go back up to your original graph, which looks like this, see the times here would be, that would be your 1 hour 8, that would be the first point of intersection. Oh, sorry, that's a different graph. We get the right graph. Here we go. So this is the 1 hour 8 minutes. So that's 1 hour 8 minutes after the first tide, which was low tide. And this is 3 hours and 8 minutes, which is after the next tide. Okay, so the point of intersection should be the same as your solution.